Hello, my name is Guido Kirsten. I'm a principal scientist at Chemical Computing Group. Today, I would like to show you how easy it is to speed up your modeling work by using parallel processes. So let's get started. On my desktop, there is an icon to start Mo. If I would use that icon as is, Mo would run a single process. Today, I'd like to show you how to leverage additional processing cores. Let's see how this works applied to the alanine scan application, which we can use to find out which residues are important for activity and stability. Let me make a copy of the Mo icon first, so that we have one icon for sequential and one for parallel processing. To utilize Mo in parallel, we must add a command line switch. I right-click on the new icon and open the Properties panel. In the target line, you see the command that is used to start Mo. To enable multiple processing, I add -MPU. I also need to specify the number of processes. You will get the best performance if you use one process per core. I know that this machine has 4 cores, so I will type in 4. If you are not sure about the number of cores, you can also force Mo to use all available cores by using hash. OK. For clarity, I will now rename the icon to Mo-MPU so that we know this is for parallel processing. This machine is running on Windows, but the steps on Linux and Mac are similar. When I click on the new icon, Mo will open, and in the header you can see the number of parallel processes in square brackets. In my case, it's 4. Now I load in a pre-prepared structure. It's an antibody-antigen complex. And to run the alanine scan, I go to Protein, Design, Alanine Scan. There is already a predefined set contact residues, which I created using the Protein Contacts application. As we are looking for important residues for affinity, I will switch on this checkbox too. Now I have 2 options. I can use the Batch button, which is the key to our HPC framework. If I click on it, I'm asked to select the folder name for the files. I will just go with the defaults. I will show you how to run these files in Batch in a minute. But for now, let's click on OK to run the calculation in the Count Graphical Mo session. As you can see in the main window, Mo will start modeling the 11 wild types and then calculate the 11 mutations. These calculations will automatically be distributed to all cores. If I open the Task Manager, you see that all 4 processors are utilized, leveraging almost 100% of the available CPU. The results will show up in the database as they become available. That might not necessarily be in the order of submission as it would be if we were running a single process. It's not only alanine scan which benefits from parallel processing. Here on this slide you can see some other applications in Mo that benefit from parallel processing. Until now, we have used parallel processes through the graphical Mo interface. Let me now show you how to do the same thing using Mo Batch. So here we have the Mo Batch command prompt from the operating system, and all you need to do is to enter Mo Batch -MPU and then specify the number of processors. Again, I could type 4 or use hash to get 1 process per core in this machine. And now I get the Mo Batch command prompt, and to check how many cores are running, I can just use MPU host count, which will tell me that we are now utilizing 4 processes. And now we can also start the batch script which we have used before. But to do that, I have to use BusyBox because I'm on Windows. And after BusyBox, I start the shell, and then I specify the complete path to the file, which is in my home directory. And I believe it's called ProDesign, and then run.sh. And then I have to use 2 hyphens because I need to pass on the next command to Mo and not to the shell. And that would be the complete command to start the shell script. That's how I can use the full potential of your hardware to speed up your modeling calculations with Mo. Easy, isn't it? If you have any questions, please do not hesitate to contact us at support@chemcom.com.